All right, sixth graders, in lesson 4.6, we're going to be talking about comparing amounts. Comparing fractions and comparing decimals and comparing percents in all of those forms, and then trying to figure out which one is more or less, which one is worth more, putting them in order from least to greatest, and things like that. So let's talk for a minute about amounts and equal amounts. We did this with finding the simplest form in equal fractions. If you have 2/3 of something, or you have 2/5 of something, can you tell which one is more based on the numbers? How do you know? Andrew?
Because if you drew the 2/3 squares would be bigger, so then the 2/5 one.
Okay, good. They both have the same top number, right?
Mm-hmm.
What does that 2 mean?
That 2 are shaded in, or 2 are filled in.
Okay, or 2 out of 3 versus 2 out of 5. Yep. So if these were, if these are the same size whole numbers, and you've got 2 out of 5, is that more or less than 2 out of 3? Jacob.
Well, that's more because if the top number is the same, well then you narrow it down to the bottom number, and
Yeah.
5 is greater than 3. So yeah.
So that means 2/5 is more?
Yes.
Wait,
No, sorry, 2/3.
why?
Well, because
5 is a bigger number.
yeah, sorry, I was confused there for a second. 2/3 is more because if you split up something into thirds, well, a third is a bigger piece than a fifth.
Correct. That's where that idea of denominators and what the denominator means comes into play here. Okay? This means that the pieces are smaller if you have 2/5. Okay? If you have a pizza that's cut into fifths and cut into 5 pieces, yeah, then the pieces are smaller than if it's just cut into 3 pieces. So you can compare the top numbers and you can compare the bottom numbers to see which one is more. Okay? Now, we use the greater than sign or the less than sign. That's how comparing them using these signs or using a number line is how we're going to be comparing them. Now, you also have to have numbers in the same form when you're comparing them. Okay? What if you had 2 numbers and one of them was 4? No, not here. Uh-oh. It's thinking.
I'm thinking 2.
Oh.
Okay.
What?
Whoa. All right. I think it's ready now. 4/5 and 0.25. Which one is more? How could you tell? What are some things that you can do when you look at these 2 numbers to tell which one is more? Are they equal?
No. Yeah. No. No.
What do we have to do? Put them in the same form. You may put them both in decimal form. You might put them both in fraction form.
You could put them in fraction form.
Okay, you could put them in fraction form. We could change 25 hundredths to 25 over 100. And then what? Come on, people, think. 25 over 100, and then what? Okay, divide them both by 5, or what's a bigger number we could divide them both by? Does 25 go into 100? Yeah. So that's 1/4. Now we can figure them out probably. Either 4/5 or 1/4. Could we tell which one is more now?
Yes.
How would you compare them now?
Well, 4/5 is almost complete. It's just short of 1/5.
Yep,
But 1/4 is short of 3/4. So
okay.
even though a fourth is a bigger piece than a fifth, it has many more of.
Right, right. One of the things you can do when you have fractions like this, even though they don't have the same denominator, so they're not the exact same size pieces, that's the most accurate way to tell. But we can estimate this because this one is more than half, and this one is less than half. Okay? If one of them is more than half and the other one is less than half, we know which one's bigger. 4/5 is bigger. 4/5 is more. Okay? So that's another way you can compare, is using half as kind of a way of determining. More than half, less than half. And then if all else fails, if you can't tell, whoops, that's not the one I want. If you can't tell based on that, then you're going to have to put them all in the same form, and then with the same denominators, or all of that, and then figure it out. So for example, number 6 on your worksheet. We have numbers, 3 different numbers, and they're all in different forms. The first one is 7/10. The second one is 82%. And the third one is 4/5. Yeah.
Yeah, it is.
And it says put them in order from least to greatest. Least to greatest. Okay? So, we have to put them all in order. We have to be able to tell, because they're all kind of close. They're all more than half. So, what do we need to do here? Can we change them all to the same form? Yeah, we did that for today in lesson 4.5. We converted them from a percent to a decimal, from a fraction to a decimal, or from a percent to a decimal and then to a fraction. It's probably easiest to convert them all to decimals. That's usually the easiest way, is to convert them all to decimals. Alright? Because we can convert this one to a decimal easily. How do we convert 82% to a decimal? You move the point. Which way and how many? Bella?
Left 2 times.
2 places to the left. So this is 0.82. Now we have this one as a decimal, this one as a decimal. How do we convert this one to a decimal? There's actually 2 ways to do this one. We can convert it to tenths, because we can write tenths as a decimal. Or we could, Maya?
You could do 5 divided by 4.
Of course you mean 4 divided by 5. The top number goes inside the house. Put the decimal points in the right place. And then divide.
Which is 8.
0.8. Or if we converted it to tenths, you have to multiply by 2, multiply by 2, and you get 8. 8 tenths. So now we have 3 numbers and they're all in the same form. They're all in decimal form. And so we can put them in order from least to greatest. Okay. Let's put them in least to greatest now. Sinji? Put them in least to greatest. Which one's the smallest?
The smallest is,
Of these three. See if this helps.
0.7.
Yeah. 0.7 is the smallest. Now we have all the same places that we can compare, right? And sometimes it's helpful to put that 0 there because there's a 2 there. And then they all have the same number of places in the number. So 0.7, 7/10, then what? Between these two. Which one is less?
0.8.
Good. And then?
0.2.
Yeah. You see, you can do this. It might take a little bit. There's a number of different steps in these problems, isn't there? Okay? But you know how to do everything. You know how to convert numbers to decimals. And then you know how to put the zeros in if you need to. Let's practice a few more examples. That was number 6. So write the answer to number 6. Let's go back to do number 1. 4 11ths and 2 11ths. Can you compare these? And if so, why? Why can you just look at these and compare them? What do they have? Andrew.
What?
What?
No.
You just checked out there for a few minutes?
Yeah.
All right. Get back on track now. Michael,
Okay.
can you help him? What does number 1 have? Why is
Oh
it
yeah,
easy-
I've already done that.
Why is 1 easy to compare?
Because they both have the same
And do they have the same top number?
No.
Talk to Michael now.
Andrew.
No, which one is more? Yeah, 4 11ths. Since they have the same denominator, the pieces are exactly the same size. And so if you have 4 of them, that's more than if you have 2 of them. That's pretty logical.
I get it. Sort of.
So we put the greater than sign in there. Do these have the same 5 7ths, 5 6ths? Ah, this is one like the very first one I gave you. The top number is the same size. So how can you tell which one is bigger in this case? Let's see who else is paying attention. Catherine. Number 2.
You need to find a common denominator. And
Oh, but do you on this one? This is just like the first example I gave you.
they have the same numerator, and the one with the smaller pieces is bigger, so 5 6 is bigger.
Okay, 5 7ths. Yeah, 5 7ths are smaller pieces, right? So if you have 5 7ths, you have less than
Yes, 9.
5 6ths. Yep. Number 3, can we convert this one to a decimal, Sophie? Sure. We just move the decimal place. Where?
Oh.
Alright.
How? Yep. 2 places to the left. Very good. And then you can easily compare these numbers. Now we add a 0 here. Now we have the same number of places to compare. So that's less, isn't it? Okay? How about number 7? What can we compare first in a mixed number? What can you compare first in a mixed number? Katie? Well, you could, but which one is going to be lowest? And how do you know? Just by looking at the numbers. The lowest. Yeah, exactly. Look at the whole numbers first. In this one, 1 and 5/12 is the lowest because that one only has one whole, versus the other have 2 holes. Okay? Then, look at these two. What do you notice about the numerators?
They're different.
What? 1/6 versus 1/4.
Oh, yeah.
1/6 versus 1/4. Now you can look at yours if you want to.
Whoa!
Oh yeah, definitely. What do you notice about those numerators in number 7? 1/6 versus 1/4.
They're divisible by 2.
Okay, both are divisible by 2. But the numerators, the top numbers in the fraction,
Both 1.
they're both 1. They're the same. So how can we compare the denominators then? Do you know?
Kind of. I think the 6, since it's bigger, is going to be less. So,
Yeah.
2 and 6, 1/6 is smaller than 2 and 4.
Exactly, it is less. You're exactly right, because 6ths are more pieces, which means they have to be smaller. You're exactly right. Okay? Any questions on these? We are using all different kinds of strategies here, which is great math. Yay, math. Right?
Grumpy cat likes math because it makes people cry.
Yeah,
I
well,
love math because it makes
I don't like Grumpy Cat. He's mean.
Well, you have a picture. It's actually a girl. You have a picture of a cat right there.
I know.
It's actually a girl. She's
But
His wife.
we can use all these strategies when you're comparing these, okay? Circle these that I want you to do for tomorrow. 1, 2, 3, and 4, 6, and 8, and 7, 10, and 11, and 9, and 13, and 14, and 15, and 16. Okay? Not 5 and 12. Good.